In this class, we're going to talk about chi-squared. Before we have any calculation, let's understand what is meant by this concept, chi-squared. Chi-squared refers to a test of statistical significance. It helps to determine whether a systematic relationship exists between two variables or not. Now, when we talk about chi-squared measure the deviation that exists between two variables. You understand? That is the simple analogy behind this concept. Are you paying attention? Okay, so there are two conditions that I want you to know. Okay, there are two conditions that I want you to know. This is a typical representation of chi-squared. You see, this one means calculated chi-squared. You understand? Are you paying attention? This is the symbol for calculated chi-squared. Calculated chi-squared. Are you paying attention? Now you will have something like this. This is what we call tabulated chi-squared. Tabulated chi-squared. This one is given on the table. You understand? Don't worry, I'm going to explain. Okay, so I just gave you the symbol. Now the reason why I bring this out is because there are two conditions that I want you to understand as far as this topic is concerned. Okay, the first condition is that if the calculated chi-squared is equals to 0, are you paying attention? If the calculated chi-squared is equals to 0, this implies that the observed and the expected frequency agree. That is, there is no deviation. You understand? That means there is relationship between the observed and the expected frequency. There is relationship between the variable that we are dealing with. You understand? You know, chi-square tells us the differences or the relationship that exists between two variables. Okay. Now, if the value of calculated chi-squared, you understand? Listen. If x squared c is equals to 0, this implies that there is no deviation. You understand? There is no deviation between the expected and the observed frequency. Okay, there is no deviation between the observed and the expected frequency. Now, another condition is that if the calculated chi-squared, that is x squared, okay, let me just put it, x squared is equals to, okay, is greater than 0. This implies that there is deviation. You understand? Are you paying attention? There is greater discrepancy. That is, there is inconsistent. There is deviation between the observed and the expected frequency. Now, mathematically, chi-squared can be expressed as this. You know, now I'm talking about the calculated chi-squared. Don't forget that I told you the tabulated chi-squared is given on the table. You understand? And it might even be given in the question. Are you paying attention? So now, to determine the calculated chi-squared, the calculated chi-squared is given by this formula: summation of the difference between the observed and the expected frequency all over the expected. You understand? This is the formula. You understand? The difference of the square of the observed and the expected frequency divided by the expected frequency, their summation will give us the calculated chi-squared. Do you understand? Okay. Now, before we delve into work example, I'm just giving you the concept. I'm giving you the concept because all these are important so that you will not, so as for you to understand some terms that we're going to be talking about when we're dealing with the calculation. Okay, so that is the formula for chi-squared. Okay, another important thing that I want you to understand is the degree of freedom. You understand? What do we mean by degree of freedom in chi-squared? The degree of freedom tells how much freedom the data has to vary while still meeting certain condition. That is the simplest definition of degree of freedom. You see, I'm going to explain. In statistics, we have two degrees of freedom depending on the chi-square test. Are you paying attention? In statistics, we have two degrees of freedom depending on the chi-square test. You know, the type of chi-square test that we're dealing with will tell us the degree of freedom that we're going to use. You understand? Now, there are two tests in chi-squared. Number one, the goodness of fit test. Hello, there are two tests in chi-squared. In chi-squared, the first test is the goodness of fit test, and the second test is the test of independence. You understand? Each of these tests uses different sets. You understand? This makes the degree of freedom to be different. You see, we're going to have work example on each test. You understand? So you just have to pay attention, okay? Just be putting the notes down, okay? Now, each of the tests uses different set. That is, there is something called contingency table. We are still coming there. Each of these tests uses different sets, which makes the degree of freedom to be different. Now, the goodness of fit test, I want to explain that now. The goodness of fit test is used to compare observed data to expected data for one variable. You can see now. Now, so if we have a chi-square in which we have only a single variable, that means that this chi-square test is for the goodness of fit test because we are only having a single variable. You understand? So when you are given a question and you are asked, what type of test is this? Look at the variable that you have. Example is a die. You can be given you can be working on a die. You can be working on a die, and you are asked to test for this so things. This the type of chi-square is goodness of fit test. You understand? Because we are only having one variable. Okay. Now, that is all about goodness of fit test. For the goodness of fit test, the degree of freedom is n-1 because we are only having one variable. Hello. The goodness of fit test, the degree of freedom for the goodness of fit test is n-1. You see, the reason why I'm giving you this explanation is because all these are important in your calculation. You understand? If you didn't understand this concept, you won't be able to comprehend the calculation itself. Okay? So, when you are dealing with goodness of fit test, which involve one variable, a chi-square test that involve one variable is known as goodness of fit test. So, when you are dealing with that type of chi-square, the degree of freedom is n-1. Okay? Now, the test for independence is used to check if two variables are related using a contingency table. Okay? I'm very sure, if not, you will have come across some table like this on a chi-square. You will have something like this. Where you're going to have one variable here. Okay? You can have one variable, the first variable, the second variable, x1, x2, x3, y1, y2, y3. You understand? Now they are not going to be you are going to be asked, maybe this variable 1 and variable 2 are related with respect to all these subsets that you are given. You understand? Don't worry, okay? All you have to do is just to pay attention, okay? So this is a typical representation of a contingency table. You understand? So when we are dealing with test for independence, the test for independence tells maybe there is relationship between two variables. On a contingency table, we have two variables, which are variable 1 and variable 2. You understand? So, chi-square test, we have more than one variable. You understand? In this type of chi-square test, that is for test for independence. You understand? That type of chi-square, there is more than one variable, and the goal is to determine how the variables that we have are related. Okay, let me quickly explain what is meant by contingency table. Don't forget that this is a typical representation of contingency table. You see, all these cells will contain some values. You understand? Okay, so a contingency table is a table used to organize and summarize data to show the relationship between two categorically variables. You understand? Okay, a contingency table refers to a table used to organize and summarize data to show the relationship that exists between two categorically variables. You see, a contingency table is characterized by row and column. You see, variable 2 belongs to row. You understand? This is for row 1, y1 is for row 1, y2 is row 2, and y3 is row 3. You understand? And variable 1 is on the column. The first column is for x1, which is under variable 1. You understand? The second column is x2, the third column is x3. You understand? I'm just trying to explain what you have on the board. Okay? So a contingency table is characterized by row and column, where each row represents the categories of one variable and each column represents the categories of another variable. You can see? Okay? Now, another thing that I want you to understand Another concept that I want you to understand before we delve into calculation is the hypothesis. You understand? Hypothesis. We have known hypothesis and alternative hypothesis. You understand? Hypothesis refers to a statement about the relationship in independence, relationship or independence in the data set. Let me just put it like that. Okay. Hypothesis refers to a statement about the relationship or independence in the data set. For example, you can, okay, let's use this contingency table. We have two categorically variables, which are variable 1 and variable 2. Variable 2. You understand? Now, in this, the goals of this is to determine whether there is a relationship or independence. You understand? If there is a relationship, that means that one variable depends on the other. That is, the effect of one variable affects the other. Now, if it is independent, that is, there is no relationship. You understand? So now, if you can see, the goals of this is to determine whether there is a relationship. Now, there is something called hypothesis. Hypothesis is a statement. You understand? Hello? Hypothesis is a statement about the relationship, you understand, that exists between our data set. Now, hypothesis is just like assumption, you understand? It's a statement of assumption that you make about a situation or a relationship, you understand? And it is tested through research or analysis and others like that, okay? Now, in chi-squared, pay attention. In chi-squared, the hypothesis is to test whether there is no effect or there is effect on the relationship between the variable that we have on the contingency table, like I've already explained before. Okay? Now, let me give you the two hypotheses in chi-squared. The first hypothesis is null hypothesis. Null hypothesis. Null hypothesis is usually represented by these signs, H naught. Okay? H naught. Now, when we are talking about null hypothesis, in this hypothesis, the assumption is that there is no effect or relationship between our variable. You understand? Hello? Don't forget that I explained what is meant by hypothesis. It's just like a statement. You are going to see all this as we delve into calculation, okay? Hypothesis is just like a statement. Now, a statement whether there is a relationship or there is no relationship. Now, we are talking about the hypothesis that we have in a chi-squared, and the first hypothesis is null hypothesis, which is represented by H naught. Now, in this hypothesis, the assumption is that there is no effect or relationship between our variable. Example, let's say we want to study the effect that gender has on I'm just looking at on voting preferences. Okay, now let's say we want to study the effect that gender has on voting preferences. If it is null hypothesis, the gender will have no effect on voting preferences. Hello? If the hypothesis is null, okay, another question arises in your heart. You are trying to ask me that, how do we know maybe we have null hypothesis or we have the second hypothesis, which I'm going to discuss as well in this video. You want to ask me? Yeah, don't worry, we are still coming there. I'm just trying to explain what is meant by null hypothesis right now, okay? In null hypothesis, the assumption is that there is no relationship. For example, I gave you an example just now. Let's say we want to determine the relationship, we want to test maybe gender has effects on voting preferences. You understand? Now, in null hypothesis, the gender will have no effect. You understand? Because the assumption is that there is no effect in the relationship in the categorically variable that we are dealing with in our there is no effect between the categorical variable that we are dealing with in our chi-square test. You understand? So gender will have no effect in null hypothesis. Don't worry, I'm still going to explain how you are going to know maybe this is null hypothesis when we accept or reject. You understand? Now, the second hypothesis that we're going to talk about is the alternative hypothesis. Okay? Alternative hypothesis. In alternative hypothesis, okay, let me just give you the symbol. Alternative hypothesis is represented by this. You understand? HA, alternative hypothesis. Alternative hypothesis, in this hypothesis, the assumption is that there is a relationship or effect between the variable being studied. You understand? If we use the same example between gender and voting preferences, In alternative hypothesis, the assumption is that there is a relationship between them. That is, gender has effect on voting preferences. That is, gender determines the person that the populace want to vote for. So that is the effect. You understand? So that is for alternative hypothesis. Okay. Now, having explained the concept, I'm very sure you understood all this. Now let us go into work example. Okay. I want to write the question down. Okay, let's consider the question on the screens. We are asked to find out whether anxiety and social interaction are related, given the contingency table below. We have the anxiety, we have no, low, medium, and high, and we have the interaction on the row side. We are given that the critical value at 3 degrees of freedom and 5% level of significance is 7.82. Okay, so how do we solve this question? If you want to solve this question, the first step is that you have to take the row total and the column total. You understand? Just pay attention, okay? You know, in our previous class, we learned that chi-square test, whether there is a relationship between two categorically variable that we have on our contingency table. The first category is what? Anxiety, and the second is the interaction. Are you paying attention? Now, anxiety belongs to the column. You understand? We have low, medium, low, medium, and high. And for the interaction, we are having interaction or no interaction. You understand? Okay? Please, I want you to pay attention. Don't forget, in our previous class, I gave you this formula: x squared calculated chi-square is equals to the summation of the observed minus expected squared all over the expected. This is the formula for chi-square. If you want to determine the calculated chi-square, this is the formula that you are going to use. You understand? Now, let's take it step by step. Let us first determine the row total and the column total. You see, in some question, you might be given the total, but in this question, we are not given the total. So we are asked to find the total by ourselves. Okay? So I'm going to have total here, and in this place as well, I'm going to have total. Total. You understand? This will be the total of the row, and this will be the total of the column. You understand? Okay, let us start with the row. Okay, for the interaction, we have 3 plus 4, that is 7. 7 plus 8, that is 15. 15 plus 10, that is 25. Okay, so here I'm going to have 25. Okay, now for the second row, which is no interaction, we have 9 plus 11, that is 20. 20 plus 8, that is 28. 28 plus 3, that is 31. So here I'm going to have 31. Do you understand? Okay, for the column, we have no. 3 plus 9, that is what? That is 12. Okay, now for the low, we have 4 plus 11, that is 15. And for this, we have 8 plus 8, that is 16 rather, sorry. 10 plus 3, that is what? That is 13. Now, having taken the total of the row and the column and total of the column, add 25 plus 31, that is 56. Okay, 56. And if you sum this together, 12 plus 15 plus 16 plus 13, you are still going to have 56. Now, if you sum yours, if you had your total, the row total must be equal to the column total. You understand? By the time you sum 25 and 31, we got 56. If you sum 12, 15, 16, and 13 as well, you must as well got 56. If you didn't get 56, that means that something is wrong. You have to check your calculation. Okay, so now, having taken the row total and the column total, the next step is that we have to calculate the expected value. You understand? Please pay attention. We have to calculate the expected frequency or the expected value. In this chi-square table, we are given the observed value. The value that we are given is they are the observed value. You understand? These are the observed value: 3, 4, 8, 10, 9, 11, 8, and 3. They are all observed value. Now we are asked to calculate we need the expected value, because in the chi-squared, calculated chi-squared, we have summation of the difference between the observed minus expected value. You understand? So we are given the observed value, which are this. Now we need to calculate the expected value. Okay, so that's why I want you to pay attention. I want to teach you how to calculate the expected value. I'm going to give you a formula and I'm going to give you a tip so that you will not make mistake. Okay, so I need your attention. Now, to calculate the expected value or the expected frequency, you can make use of this formula. Okay, the formula is, okay, let me just put it, expected value is equals to FRS multiplied by FCS all over N. I'm going to explain all the meaning of FRS and FCS. Just master the formula. Expected value is equals to FRS multiplied by FCS all over N. You understand? Now, FRS simply means the frequency of the row summation. You understand? The summation of the row. The summation of the frequency of the row. That is FRS. FCS means the summation of the frequency of the column of the value of the expected value that you want to calculate. Don't forget that we have different observed value. We have 8 observed value in this contingency table. Okay, let me quickly ask you a question. In our previous class, we talked about test. When we're talking about chi-square, we have 2 tests. We have number 1 is what? Goodness of fit test, and the second is what? Test of independence. Now, the question is that what type of test is this? Is it goodness of fit test or test of independence? If you say it is goodness of fit test, you are not part of our course class. That means you missed it. You understand? You didn't get it right. If you say good test for independence, you are correct. Because in our previous class, we learned that test for independence is used to test maybe there is a relationship between 2 categorically variables. In this case, we have anxiety and interaction. You understand? I just bring that up so that you have to understand the basic concept that we discussed in our previous class so that you will know all the rudiments that associate with this topic. You understand? Okay? So, the expected value is given by this formula. Okay? Now, on this contingency table is a table that shows the relationship that exists between anxiety and interaction. Now, on this contingency table, we have 8 observed value. Now, we need to determine the expected value of this 8 observed value. You understand? Okay? Now, in an attempt to determine the expected value of this 8 observed value, we're going to take each one by one. Are you paying attention? So that is the reason why I bring out this formula. The formula is FRS, that is frequency of the row summation multiplied by frequency of the column summation all over N. Now, let's say I want to determine the expected value of 3. Hello? I want to determine the expected value of 3. Let me start it. That is the first observed value there. Let's say we want to determine the expected value. You see, I just represent it here. Expected value of 3. Expected value of 3. Okay, this 3 is the observed value. You understand? I want to determine the expected value. Now, that will be frequency of the row summation that 3 belongs to. Hello? Pay attention. You are going to understand, okay? I want you to understand. Now, let's say we want to determine the expected value of 3. That will be frequency of the row summation which 3 belongs to, multiplied by frequency of the column summation that is corresponding to 3, all over N. N is the total numbers of the elements that we have on our contingency table. The summation of all the elements that we have on our contingency table is N. Do you understand? So we want to determine the expected value of 3. That means that I'm going to have the frequency of the row summation that 3 belongs to. Now, 3 is here. The row summation is what? 25. So 3 belongs to 25. You understand? Okay? In the row summation, the summation of the row which 3 belongs to is what? 25. So I'm going to have 25 multiplied by FCS. FCS means what? Frequency of the column summation. Now, The corresponding frequency of the column summation which 3 belongs to is what? Is 12. You understand? This is the expected value that we want to determine. We have the observed value which is 3. Now, frequency of the row summation is 25 and the frequency of the column summation is what? 12. Now, when you are dealing with this type of question, just have this at your mind. You understand? If you want to determine if this is the you want to determine the expected value for this element that is here, know that you are going to trace it to the extreme end which there is total. You understand? You are going to trace it to the extreme end here as well which there is total. You understand? That is what I did. Trace it to the extreme end, that is 25. Trace it to the extreme end, that is what? 12. Now, that's with 25 times 12. You understand? So here I'm going to have 25 times 12 all over n. Don't forget, n is the total numbers, the summation of all the frequency, the summation of all the observed value on our contingency table. That is the value of n. And if you add all of them together, you're going to have 56. So in this case, n is 56. Do you understand? So you can put 56 there. Or you can put 56, okay? Here, I'm gonna have 56. Okay, so now 25 multiplied by 25 multiplied by 12 divided by 6 divided by 56, that is 5.36. So here I'm going to have 5.36. Do you understand? So the expected value of 3 is what? 5.36. Do you understand? Okay, let us proceed to the expected value of the next observed value. That is what? 4. Do you understand? So I'm going to trace it to the extreme end, which is what? 25, and I'm still going to trace it to the extreme end as well, which is for the column. That is what? 15. So for the expected value of 4 will now be 4. Frequency of the whole summation, that is 25. So I'm going to have 25 multiplied by 12. Oh, okay, not 12 now, sorry. 25 multiplied by 15. 25 times 15 all over 56. Okay, let me quickly punch my calculator here. 25 times 15 25 multiplied by 15 all over 56, that is 375 divided by 56. 375 all over 56, and if you divide this by your calculator, you're going to have 6.70. okay, so that is 6.70 here. 6.70. okay, now let me quickly prepare another table. I want to quickly prepare another table. Okay, that will be for the expected value. So for the expected value, now I'm going to have this. One, two, three, four, five. Okay. Okay. Expected. This is the expected. Okay. This. We have total here. So we have interaction. We have no interaction. You understand? We have no, low, medium. We have high, and we have total. Okay. Now we have already gotten the expected value of 3. So the expected value of 3 was 5.36. So I'm going to have a 5.36. Now for 4 is what? 6.70. So I'm going to have 6.70. Do you understand what I'm doing? As I'm getting the expected value, I'm just putting it in the table expected. Let me call this expected. You understand? This is the table for my expected value. You understand? So I've already gotten 3 and 4. So you can do the same for 8, 10, 9, 11, 8, 3. You can do the same. You're still going to arrive at some answer. Well, I'm going to do some, but I'm not going to do everything. You understand? So as to save time. Okay. So let's get the expected value of 8. I'm going to do this row. You can do the rest by yourself, okay? Let's get the expected value of 8. So, to get the expected value of 8, that will be, you see, frequency of the whole summation that 8 belongs to. That is 25. So I'm going to have 25 multiplied by frequency of the column summation. We are here. Frequency of the column summation, you trace it to the column, the total is what? 16. So that is what? Divided by 16 all over the total numbers of frequency. That is what? 56. So I'm going to have 56 here. So if you point your calculator, 25 multiplied by 16, 25 times 16, that is 400. 400 divided by 56. 400 all over 56. 400 divided by 56, that is 7.14, okay? 7.14. So here I'm going to have 7.14, and for the next cells, I'm going to have for 10 now. We want to do that for 10. That will be frequency of the whole summation, that is 25. 25 multiplied by 13 divided by 56. If you point your calculator, you're going to have 5.80, okay? Here I'm going to have 5.80. Now, I'm very sure you can do this. You can do for the expected value of no interaction. Look, we want to determine this now. We are here. The expected value for 9 will be 31 multiplied by 12 divided by 56. Do you understand? Frequency of the whole summation which 9 belongs to. The frequency of the whole summation which 9 belongs to is what? Is 31. And the frequency of the column summation which 9 belongs to is what? Is 12. You understand? So I'm going to have 31 multiplied by 12 divided by 56. Do you understand? So for 9, the expected value is 6.64. Okay? So here I'm going to have 6.64. And for this place, I'm going to have 8.30. And for this, I'm going to have 8.86. Here, I'm going to have 7.20. Do you understand? Okay? So now, I want to do something. You know what you're going to do now. I want to add all these values together. Add all these values. 5.36 plus 6.70 plus 7.14 plus 5.80. You are still going to arrive at 25. All this is going to give 25. Why? When you add this 6.64 plus 8.30 plus 8.86 and plus 7.20, you are still going to arrive at 31. So here you are going to have 31. You're going to have 31 here. So if you add this and this together, you're going to have 12. Here you are going to have 15. Here you're going to have 16. Here 13. And the total will be what? 56. Okay? Please, do you understand what I'm doing at all? If you don't understand, listen to the explanation again, okay? If you make use of this formula, you're going to arrive at this exact value, okay? So these are the expected value. We've already gotten all of them. Now, permit me to erase all this. Let me erase this so that there will be space for our table. Now, since we have gotten all our expected value, the next step is that we have to prepare our chi-square table. You understand? Now, the table is going to be with respect to the parameters that we have in this formula. You understand? We have the observed value. So the first column will be for the observed, and the next column will be for the expected. You understand? You see, the formula for chi-square will tell you what you're going to have on the table. Okay? So we have the observed, we're going to have the expected as well. So the next column will be observed minus expected. You understand? Because from the formula, I need the difference between the expected and the observed. Okay? So the next column will be the observed minus expected squared. Because I need the square of the differences. Okay? And the next column will be observed minus expected squared all over expected. You understand? You see, what I have in this formula is what I put on the table. You understand? Observed value has been given. So I'm going to have 3. Let us first write out the observed value, okay? The first value there is what? 3. So I'm going to have 3. The next value is 4. The next is 8. The next is 10. Okay, we have 9, we have 11, and we have 8, and we have 3 as well. Okay, let me do this. Do you understand what I'm doing? You see, I need to calculate the calculated chi-squared so as to know the hypothesis testing. You understand? And that is why I have this table. To calculate the calculated chi-squared, I need to, this is the formula for calculated chi-squared. So I want to do that. So I need all this value. You understand? So I've already filled the observed value. Now, the expected value, the first for 3 is what? 5.36. 5.36. For 4 is 6.70. For 8 is 7.14. 7.14. Let me write it very well. 7.14. For 10, it is 5.80. 5.80. For 9, it is 6.64. For 11, it is 8.30. For 8, you know, this is 8. That is 8.86. 8.86. Then for 3, it is 7.20. 7.20. Do you understand what I did? This is the observed we have been given, and this is the expected that we got. You understand? Okay. Now I need their differences. Let me do this so that you will not be confused. Sorry. Okay, so I need their differences. Now, for the value of these cells will be observed minus expected. So this is the observed, this is the expected. So I'm going to have 3 minus 5.6 to get the value of these cells. Do you understand? 3 minus 5.36, sorry. That is negative 2.36. Negative, let me use blue pen. Negative 2.36. 4 minus 6.70, that is negative 2.70. 8 minus 7.14, that is 0.86. Okay? And 10 minus 5.80, that is 4.20. So here, 9 minus 6.64, that is 2.36. And 11 minus 8.30, that is 2.70. 8 minus 8.86, that is negative 0.86. Okay? Now for this, I'm going to have 3 minus 7.20, that is negative 4.20. Do you understand? Okay? Now, the next cells is observed minus expected squared. So I've already taken the differences. So the value of these cells will be the square of individual of these cells. Do you understand? The square of the individual cells of the square of the individual cells will be the values of these cells. So if I want to get this value, I'm going to square negative 2.36. Negative 2.36 is 5.5696. 5696. Okay, the value of these cells will be negative 2.70 squared. That will be 7.29. And this 0.86 squared, that is 0.7396. 0.7396. Okay, the value of these cells will be 4.20 squared. That is 17.64. Then this will be 2.36 squared. That is 5.5696. 5.5696. So here I'm going to have 7.29. Here I'm going to have 0.7396. And here we're going to have 17.64. 17.64. Okay, so I square all these to get all these values. You understand? Okay, so the next step here will be the square of the difference divided by the expected. You understand? You see, all this is very important. You understand? Those are the basic concepts that you have to understand in statistics. Okay, having squared the differences, I got all these values. Now the value of these cells will be observed minus expected. That is, after squaring the differences, I'm going to divide the answers by the expected value. You understand? So here, for this, I'm going to have, please just pay attention, okay? For this cells, I'm going to have all this value divided by the expected. I'm going to get the value of this cell. So for the first cell here, I'm going to have 5.5696 divided by 5.36, because the expected that correspond to 5.5696 is what? 5.36. So this will give me, what's the answer? That is 1.0391. 1.0391. So here I'm going to have 1.0391. Do you understand? Okay, let's proceed to the second cell. For the second cell, I'm going to have 7.29. 7.29 all over the expected that correspond to 7.29 is what? 6.70. 6.70. So here I'm going to have 1.0881. 1.0881. Do you understand? Okay. Now let's get the value of these cells. What are we going to square? What are we going to divide? We're going to divide this by 7.14. So I'm going to have 0.7396 all over 7.14. This is the expected that corresponds to 0.7396. The value of that one is 0.1036. So 0.1036. So if you do the same, the 17.64 divided by this, that will give us let me check. 17.64 divided by 5.80. That is 3.01. Okay, 3.0414. 3.0414. For this, we are going to have 0.8388. 8388. For this, I'm going to have 0.8783. For this, I'm going to have 0.0835. For this, we are going to have 2.45. 2.45. You understand? So these are the values that are going to have by the time you divide these cells by these cells. You understand? Okay. The reason why I show this on this table is because I want you to understand. Okay. So if you are working in an exam, you didn't need to put this fraction. You understand? Just know that it is the square of the square of the differences is divided by the expected. That's what we are going to do to get the value of these cells. You understand? Okay. So now, having gotten this, the observed minus expected squared all over expected squared, we need the summation. You understand? The summation simply means the addition of all those values. You understand? That will give us the calculated chi-squared. You understand? Because you can see at the front of the bracket, you can see this sign. This sign means summation. Okay. So if you sum all these values together, you're going to have 9.5228. 9.5228. So here I'm going to have 9.5228. That is the calculated chi-squared. Hello. Let me write it at the front. You understand? 9.5228. Okay. 9.5228, and that will be to 2 decimal place. That is 9.52. You understand? That is the calculated chi-squared. Now don't forget in the question that we've been given that the critical value, that is the tabulated chi-squared. Okay, at 5% is what? 7.82. So here the critical value on the table now is what? 7 point at 5%. Okay, let me put it, is equals to 7.82. Don't worry. You see, in some cases, you might not be given the critical value in your question. You understand? But they can give you. You're going to be given like maybe at 5%. They might not give you the exact value. Hello. Listen to what I'm saying. You see, in this question, we've been given that the critical value at 5% is what? 7.82. But there are some cases whereby you are not going to be given the level of significance, the critical value. You understand? So in that case, you're going to look for it on your table. Okay, now I'm going to teach you how to use that, how to check that on the table. Okay, by the end of this class, I'm going to teach you how to do that. Now, so the critical value at 5% is what? 7.82. So now we have gotten the calculated chi-squared. We know the critical value is what? 7.82. And we learned in our previous class that hypothesis testing, we have null hypothesis and alternative hypothesis. In null hypothesis, the assumption is that there is no relationship, that is, there is no corresponding relationship, there is no relationship between the categorically variable that we are dealing with on our contingency table. You understand? Now, that is for null hypothesis. Now, for alternative hypothesis, that means there is a relationship between the categorically variable that we are dealing with on our contingency table. In this case, we are dealing with two variables. The first variable is anxiety, and the second is what? Interaction. You understand? So, if it is null hypothesis, that means there is a relationship between the that means that there is no relationship between anxiety and interaction. Now, if it is alternative hypothesis, that means that there is a relationship between anxiety and interaction. Now, how do we know if there is a relationship or there is no relationship? That is what I want to answer right now. So I want you to pay attention, okay? If the tabulated chi-square, look, listen. If the tabulated chi-square is greater than the calculated chi-square, we are going to accept the null hypothesis and reject the alternative hypothesis. You understand? And please pay attention, if the calculated chi-square is greater than the tabulated chi-square, we are going to accept the alternative hypothesis and reject the null hypothesis. Do you understand? Now, look at what we have here. We have the tabulated chi-square at 5% and degree of freedom of 3. Oh, let me quickly show you how to calculate the degree of freedom. You see, the degree of freedom for a contingency table is given by this formula. Please pay attention. You know, I told you that we have test for independence and we have goodness of fit test. In test for independence, we make use of contingency table. You understand? So the degree of freedom for a contingency table, for a chi-square that involves a contingency table, the degree of freedom is given by this formula. The degree of freedom is equals to R minus 1 multiplied by C minus 1. Do you understand? I'm going to explain. Look, the meaning of R means that the numbers of rows that we have, and the C means the column that we have. You understand? Now, if I'm to calculate the degree of freedom for this data, please pay attention. If I'm to calculate the degree of freedom for this data, I'm going to have degree of freedom is equals to the row that we have is what? We have two rows, which is 1 and 2. So I'm going to have 2 minus 1 multiplied by C minus 1. How many columns do we have? We have 1, 2, 3, 4. We have 4 columns. So I'm going to have 4 minus 1. So here I'm going to have degree of freedom is equals to 1 multiplied by 3. Because 2 minus 1 is 1. 4 minus 1 is 3. 1 times 3 is what? 3. So the degree of freedom is 3. Do you understand? Okay, so now the tabulated chi-square, that is the chi-square that we are given on our table, the chi-square that we are given in the question, the tabulated chi-square is what? Is 7.82 at 5% and 3 levels of degree of freedom. Don't worry, I'm going to show you how to get it using the table at the end of this class, okay? So the degree, the critical value or the tabulated chi-square is what? 7.82, but the calculated chi-square is what? 9.52. You can see that in this question, in this question, the calculated chi-square is greater than the tabulated chi-square. And I have already told you that if the calculated chi-square is greater than the tabulated chi-square, we are going to accept the alternative hypothesis. You understand? We are going to accept the alternative hypothesis, which implies that there is relationship between anxiety and interaction. You understand? We are going to accept the alternative hypothesis and reject the null hypothesis. Please, I'm very sure you understood what I just said. If you didn't understand, listen to the explanation again, okay? It's easy. We have two hypotheses. We have the null hypothesis, we have the alternative hypothesis. Now, depending on the values of our the calculated chi-square and the tabulated chi-square, that will depend on which hypothesis we are going to accept or we are going to reject. Now, because the calculated chi-square is greater than the tabulated chi-square, we are going to reject the null hypothesis that anxiety has no effect on social interaction and accept the alternative hypothesis that anxiety has significant effect on social interaction. Do you understand? Okay, so now having gotten this, I'm very sure you understand this. Let me show you how to use the table to determine the critical value or the tabulated chi-squared. I'm going to show you using the table now. Okay, so I want you to pay attention. This is a typical representation of a chi-square table. You understand? The table for our critical values. This is how the table look like. On this table, we have
degree of freedom at the extreme left. You can see D here. That is the degree of freedom. You understand? Now, this degree of freedom ranges from 1 to 20. There are some chi-square table, the critical values table for chi-square distribution that have more than 20. You understand? But this table has 1 to 20, and it is enough to show you what I want to show you. Don't forget that we calculate our degree of freedom as 3. You understand? So the degree of freedom on this table, we're going to locate 3. Okay, you can see 3 in this place. You can see this is 3 now, and the level of significance that we are given is what? 5%. So we are going to check 3 and degree of freedom for 3 under 5% level of significance. You know that 5% simply means 5 all over 100. Okay, so and if you check 5 divided by 100, that will give you what? 0.05. so we're going to check 3. This is 3. So having identified the degree of freedom, that is 3. Now you know that we are given that the level of significance is what? 5%, and I told you that 5% simply means 5 all over 100, and that is 0.05. so you can see 5% here. This is 5%. Okay, let me put it here. This is 5%. So I'm going to trace it downward to where we have 3 degree of freedom, and if you trace it downward, you are going to realize that we are going to have that is 7.815. okay, that means that the critical value at 5% on this table, you understand, that is the tabulated chi-squared. The tabulated chi-squared at 5% is what? 7.815. You understand? If you do understand how to use the table, let me know in the comment section. Okay, so that is how to determine the critical value. Let me test you now. Let's say the degree of freedom is 2 and the level of significance is 5%. What will be the critical value? The critical value, the first step is to identify 2 on your degree of freedom, and you can see that here is 2. We have 2. This is 2. You understand? And so, and you know that 5% is 0.05. so all you have to do is to trace it downward to the figure, the values that correspond to 2 degree of freedom. That is 5.991. okay, so the critical value is 5.991 if the degree of freedom is 2 and the critical value, the level of significance is 5%. The critical value will be 5.991. so after all, our degree of freedom, our critical value for the question that we are dealing with is 7.815. so if you approximate, you are going to have 7.82. that is why we have 7.82 as the given critical value. Do you understand? Okay, so that is how to determine the critical value, peradventure, if you are not given in the question. Okay, so that's all.
In this class, we're going to go over chi-squared. We're going to learn how to test for the goodness of fit in chi-squared. Okay, let's start with the first example. A die is tossed 120 times with the following results. You can see the results. We are asked to test the hypothesis that the die is unbiased. You can see that this type of question is goodness of fit test because we didn't have a contingency table. You understand? Okay, so if you want to test whether the die is unbiased or it is biased, the first step is that we have to prepare our table. You understand? Don't forget that in our previous class I told you chi-square is given by this formula. Calculated chi-squared is equals to summation observed minus expected squared all over expected. You understand? This is the formula for chi-squared. You understand? The calculated chi-squared. Now in the question we are given that the tabulated chi-squared is 11.07. 11.07. Let me write it here. 11 points. That is the critical value. 11.07. I'm going to show you how they got this value using the table. You understand? Because in some question you might not be given this value. You will be asked to determine the value by yourself through the table. You understand? There is a table whereby you are going to get this. Okay, so let's proceed. We have to prepare our table. You understand? So the table will contains observed and the expected value. In the question, we've been given the observed value. We have the numbers of phase turned up and we have the frequency respectively. You understand? So let's start. So I've already prepared the table. You see, the numbers of turn up is also the same thing as the numbers of phase. You understand? The phase number in a die is what? We have 6 phases. We have 1, 2, 3, 4, 5, 6. You understand? So don't be confused. The numbers of turn up is also the same thing as the numbers of phase that we have in a die. Okay? Now we are told that this die is toast how many times? 120 times. That means that the total numbers of frequency that we must have must be equal to what? 120. So here I'm going to have 120. 120. Okay? Because the die is toast how many times? It is toast 120 times. So the total numbers of frequency, all this must be equal to what? 120. Okay? So we have been given the observed value. The observed value are the frequency that we are given. Okay? The observed value are the frequencies that we are given. We are given for phase 1. Okay, I think I must have another table. Okay, let me call it phase. Okay? Phase. We have the observed value, we have the expected, we have the observed minus expected, we have the observed minus expected squared. Please pay attention. This formula will tell me what I'm going to have on this table. You understand? In this formula, I need the observed value. Okay, we need the observed value. The observed value are the frequencies that were given. You understand? The frequency that we are given in the question is the observed value. Now, I'm going to determine the expected value. Don't worry, I'm going to teach you, okay? Now, from this formula, I still need what? Observed minus expected. That's why I have this. From this formula, I still need the square of the differences between the expected and the observed value. So I have this. Now, I have to create another column. I need another column. So, I'm going to have additional one here. Okay, so here we stand for observed minus expected squared all over expected. You understand? Because according to this formula, I need the summation of this to get the calculated chi-squared. Do you understand? So this formula tells me what I'm going to have on this table. Okay, so now the phases are what? Phase 1, 2, 3, 4, 5, 6. You understand? You might not include the phase on your table. You understand? But I just want you to understand. That's why I include it. Okay. So the observed value for phase 1 is what? Is 30. The observed value for phase 2 is what? 25. The observed value for phase 3 is what? 18. For phase 4 we have 10. For phase 5 we have 22. For phase 6, we have 15. Okay? Now, what of the expected? How do we determine the expected? Now, please pay attention. Don't forget that the test we are dealing with is what? Goodness of fit test. We are asked to test if the die is unbiased. If the die is unbiased, the numbers of phases shown must be equal. You understand? When the die is toast, I pay attention. If the die is toast, the numbers of phases shown must be equal for all the observed value. So, in an attempt to determine the expected value, you just have to take the total numbers of frequency that you have, which is what? 120, and divide it by the numbers of phases in a die. Listen to the explanation again. Okay? Listen. You see, if there is no bias, you understand? If the die is unbiased, if you throw the die 120 times, the numbers of phase shown must be equals for all the numbers of observed value must be equals for all the phases. You understand? That is, the expected value will be 120 all over the numbers of phase. That means that will be equals to what? 20. That is, 1 must appear 20 times. So the observed value must be equal. That is 20. If you didn't understand, listen to the explanation again. If the die is unbiased, the die is thrown 120 times. That means that for all the faces, we must have 20. You understand? And how do I got 20? I divide 120 by 6 because the numbers of faces in a die is what? Is 6. You understand? So here I have 20. So that means that if I throw the times, if we throw the die 120 times, that means 1 must appear 20 times if the die is unbiased. 2 must appear 20 times. 3 must appear 20 times. 4 must appear 20 times. 5 must appear 20 times. And 6 must appear as well 20 times. So the summation of this must be equal to what? 120. You understand? But from the observed value, please listen, okay? This is the observed value, this is the expected value. I'm very sure you understand now. Now, let's take the differences. Okay, let's remove this so that we will not get confused. Let's remove this. Okay, so now observed minus expected. That means for this I'm going to have 30 minus 20. Observed minus expected. 30 minus 20, that is 10. Okay, 25 minus 20, that is 5. So here I'm going to have 5. 18 minus 20, that is negative 2. 10 minus 20, that is negative 10. 22 minus 20, that is 2. Okay, 15 minus 20, that is negative 5. Okay, so here I'm going to have negative 5. Do you understand? Okay, now we need the square of the differences between the observed and the expected. You understand? So I'm going to square all these values. 10 squared is what? 100. 5 squared is what? 25. Negative 2 squared is what? 4. Negative 10 squared is what? 100. 2 squared is what? 4. Negative 5 squared is what? 25. Do you understand? Okay, so having gotten the square of the difference between the observed and the expected value, we need to divide all this value by the expected value. You understand? Okay, we need to divide all this value by the expected value. Now let's start with these cells. 100 divided by what? That is the 100 divided by 20. Okay, because the corresponding expected value for 100 is what? 20. Even though all the expected value are the same for all the faces, the expected value are the same because if the die is unbiased, the faces must show at equal numbers. You understand? At equal numbers of time. Okay, so that's why I have 20 here. So 100 divided by 20 is what? That is 5. Okay, are you paying attention? Now that will be 25 divided by 20. 25 divided by 20 is what? 1.5. 4 divided by 20. That will be 0.2. Okay. Now 100 divided by 20. That is what? 5. 4 divided by 20. That is what? 0.2. Okay. 25 divided by 20. That is what? 1.5. Okay, 1.25. 1.25. I just hope maybe there is no mistake here. 1.25. Please, let me check. I want to check this. 25 divided by 20. Okay, it is 1.25. Sorry, this should be 1.25 as well. 1.25. Okay. 25 divided by 20 is 1.25. 25 divided by 20 is 1.25. Please, do you understand? Don't make mistake, okay? If you are dealing with this in exam hall and you you get to a point maybe you are confused, just make use of a calculator, okay? Now, remember that the formula for chi-squared is what? Summation observed minus expected squared all by expected squared. So we need to sum all these values together, okay? So I'm going to have 5 plus 1.25 plus 0.2 plus 5 plus 0.2 plus 1.25. That will be 12.9. So here I'm going to have 12.9. Hence, the calculated chi-squared is equals to 12.9. Okay, now we've been given in the question that the critical value at 5%, the critical value, okay, the critical value at 5% is what? Is 11.07. Okay, so the critical value, that is the tabulated chi-square. Please pay attention. The tabulated chi-square is also known as the critical value. You understand? That is the chi-square that we got from the table. That is the critical value, or the tabulated chi-square. Do you understand? Okay, so here the tabulated chi-square, which is xt squared, is equals to 11.07. Don't worry, I'm going to show you how to get this on your table. Okay, so don't forget that xt at 5%. 5% is also the same thing as 0.05. It's what? 11.07. Okay, so the critical value is here. I mean, these are the critical value that we have. Now, how do we know maybe the die is unbiased or it is biased? How do we know if the die is unbiased or it is biased? See, if the calculated value of chi-squared is greater than the tabulated value of chi-squared, the hypothesis that the die is unbiased is rejected at 5%, at 5% level of significance. I'm going to explain, okay? You see, in this, you can see that the calculated chi-squared is greater than the tabulated chi-squared. This calculated chi-squared is greater than this. That means that the hypothesis that the die is unbiased will be rejected. You understand? And the reason is because the calculated chi-squared, that is xc squared, is greater than xt squared at 5% level of significance. So we are going to reject the hypothesis. The die is biased. You understand? The die is biased. The die is unbiased. If the die is unbiased, we are going to accept the alternative hypothesis. We are going to reject the known hypothesis. Now, the die is biased, so we are going to reject the known hypothesis and accept the alternative hypothesis because the die is biased. And how do we know that the die is biased? We knew because the calculated chi-square is greater than the tabulated chi-square. Let's say that the tabulated chi-square is greater than the calculated chi-square. That implies that the die is unbiased, so we're going to accept it. But because the calculated chi-square is greater than the tabulated chi-square, so we are going to reject the hypothesis. Don't forget that we are testing for hypothesis. That in the question we are asked to test for the hypothesis. Maybe the die is unbiased. So in this case, we're going to reject the null hypothesis. Null hypothesis means that the die is biased. You understand? Please, all these are very simple. Okay, all you have to do is just to pay attention to the explanation. Okay, now I want to explain to you how to get the critical value. You know, in some cases you might not be given the critical value in the exam. Okay, so it is important that you learn how to use the table to find the value. To get the critical value using the table, you have to know the degree of freedom. Now, because we are not dealing with contingency table, in our previous class we have learned about contingency table. You can check the description of this video to watch other classes, the previous classes. Okay, so the degree of freedom for this chi-square is n minus 1. N is the numbers of rows that we have. You understand? Hello. The numbers of rows that we have on our table will be n. Okay, and we have how many rows? We are having 1, 2, 3, 4, 5, 6. We are having 6 rows. So here the degree of freedom will be what? 6 minus 1, which is what? 5. So the degree of freedom is what? 5. Now, the critical value that we are given, please just pay attention. Okay, the critical value that we are given, is at 5%, 5% level of the 5% level of significance and 5 degree of freedom. Now let's go back to our table.
Here we have our critical values of the chi-square distribution with the degree of freedom. You understand? This is how a typical chi-square distribution table looks like. Okay, on these chi-square distribution tables we have the degree of freedom, which ranges from 1 to 20. You understand? Okay, now how do we use this table to determine the critical values, perhaps if you are not given an exam? Now, to use this critical value table to determine the critical value, all you have to do is that you first have to identify your degree of freedom. Don't forget that while I'm solving the question, the degree of freedom is what? Is 5. You understand? Okay. Also, I want to take note of something. You know that when I'm solving the question, the degree of freedom, the formula is what? N minus 1. Now, n is the numbers of sample. Are you paying attention? N is the numbers of sample that you have. So, you can have your sample in row or column. Whether your samples is in column or row, just subtract 1 from your sample. You understand? The total numbers of sample, the total numbers of elements or data that you have minus 1, that will give you the degree of freedom. Are you paying attention? So that is how I got the degree of freedom as what? 6 minus 1, that is 5. Okay, now to use this table, the first step is to identify the locate 5 in the degree of freedom, and if you check well, you're going to realize that this is 5. Okay, so D is the degree of freedom. If you check, you are going to see 5 here. And now you know that the level of significance is 5%. So 5% is also the same thing as what? 5 divided by 100. 5 divided by 100 is what? 0.05. You understand? So you can see 0.05 on the top here. This is 0.05. Let me erase it. This is 0.05. You can see. So you just have to trace it downward. You can see that when you trace it downward, you are going to realize that trace it downward to where we have 5 degree of freedom. You're going to realize that the value that is there is 11.07. Are you paying attention? The degree of freedom is 5. You have already located 5. Then the level of significance is 0.05. So you trace it downward to the value that is correspond to degree of freedom of 5. That is 11.07, as you can see. So the critical value is 11.07. Do you understand? The critical value is 11.07. So that is how to use the chi-square table to determine your critical value, perhaps if you have not given an exam. Okay, so let's say your degree of freedom is 2. I'm just going to give you a test now. Let's say the degree of freedom is 2, and you are asked to determine the level of significance is 1%, and you are asked to determine the critical value. What will be your critical value? The critical value will be 9.21. Okay, how do I know? The first step is that just locate your degree of freedom. That is 2. You can see here that is 2. Then, having identified your degree of freedom, 1% simply means 1 over 100, and 1 over 100 is what? 0.01. So this is 0.01. You can see. Now you just have to trace it downward to where you have the value that corresponds to the degree of freedom of 2. So when you trace it downward, you're going to realize that you're going to stop at 9.21. You understand? 9.21. That is the critical value for level of significance 1% and the degree of freedom of 2. Do you understand? Okay, so that will be all for this class.